I'm just going to kind of walk you through what you did last night for homework with the lab and what you're going to do today in class. So the first thing I would like you to do is pause the video so that everyone has a chance to correct and add to their work from last night. So pause the video now so everyone can do that, and then restart it when everyone's done. Okay, we're back. So what we're going to do now is I'm going to walk you through collecting the data for the data table. Okay, so I'm gonna walk you through using the simulator, and then when we're done, you're going to then continue on. Everyone will open up their MacBooks and use the simulator to fill in the rest of the data table. We're going to do June 21st together. All right, so let's go to the simulator. Here we are, and on the simulator, we're going to change the date to June 21st. So we can just drag this, or you could do it manually. Up here, you can just type it in and change the month. We're going to change our latitude to 41 north. Whoops. You know what? It's easier for me to just type it in. 41 and then return. 41 degrees north. We got rid of the ecliptic, so I know it says to uncheck the ecliptic because it just kind of makes it a little bit too cluttered. Okay. And then what we're going to do is we are going to manipulate the celestial dome with the observer. All right. And the first thing that we need to figure out is the time of sunrise or sunrise time. So you can drag the sun to sunrise. So when we go below the horizon, it's black. So you want to drag the sun until the sky changes color right there. Okay. And then you look here, and the time of day that the sun rises is 04:34. So write that down for sunrise time, 04:34. And the sunrise compass direction, it is north of east. So it's like east, northeast. So you can write in east, northeast, ENE, okay? Now we have to drag the sun to solar noon. So I'm going to kind of turn this a little. And solar noon is when the sun is at its highest point in the sky. Now, the highest point in the sky for this observer is right here. You see this line going from north to south. That's the observer's longitude. So I just drag the sun so that it's centered on the longitude. And I look here. The sun's altitude at solar noon is 72.4 degrees. So that's the sun's altitude at noon, 72.4 degrees. Write that in your data table. And the shadow length at noon. So we kind of turn this, and compared to the height of the person, that shadow is pretty what, folks? That is pretty short. So you're going to write short. All right. And the noon shadow, is it located to the north or south? Well, since the sun is in the southern part of this person's horizon, the shadow is always opposite. The shadow is facing north. So you're going to write north, N, on the noon shadow location. Okay. And then I'm going to manipulate this. I'm going to turn it around. Okay, to sunset. And I'm going to drag it over to sunset. Okay, and then I'm going to turn it a little bit more. This is what you can do. You can manipulate the dome and the sun. And right about there. Right there. Sunset. So 1930. 1930. That's sunset time. That's 7:30. 1930. Okay. And the compass direction of the sunset, well, it's not exactly northwest. It's north of west. So I would say west, northwest. So put in WNW. Number of hours of daylight. Okay, so let's go back to, you can't get that on here. You can't get the number of hours on daylight on here. But what you're going to do is you're going to go back to here. Okay. Numbers of hours of daylight. So what is the difference between 04:34 and 1930? Well, if this was 30, there'd be 15 hours, right? So the difference between 19 minus 4 is 15. There would be 15, but we're a little bit short of 15. So it's 14:56. We're 4 minutes short of 15 hours, so that you can do that subtraction when you're when you do the others, when you do the other September 23rd, December 21st, and March 20th. Okay? All right. So now we're going to take this data and we're going to draw a sun path. Now I'm writing in red. You should have been writing in pencil, obviously. I'm writing in red so you guys can see it. But I'm going to draw in pencil over here because I can't draw in pen, that's for sure. Okay. So this section says, draw the sun's path and the length of the shadow at noon for each date. Use the north, south, east, and west directions from June 21st to label the other 3 celestial domes. So what you're going to do when you continue is you're going to label the other 3 celestial domes the way this one's labeled. Okay, so we have the observer, and this is their celestial dome, and there's an external protractor here. Okay, so on June 21st, what was the noon sun altitude? On June 21st, it was 72.4. So we're going to take that, we're going to write that here, 72.4 degrees. All right, and we're going to plot that on here. So we know the noon sun was in the southern sky, right? Because we know the shadow was over here, okay? So we're going to make a dot at 72.4 degrees. So 60, 70, I know it's a little bit hard to read, but 72.4 is right there. That's the position of the sun. That is solar noon. So write that down, okay? Now, in order to draw the sun path, we need to connect this to the position of sunrise and sunset. So sunrise, this would be smack dab in between north and east. It wasn't there, it was over here. Okay, it was over here. So it was east, northeast. So that was the position of sunrise. So this right here is sunrise. So this person looked here to see the sunrise. And sunset was west of northwest. So we're going to make the dot for sunset parallel to this line. So if you look at this line and we make that parallel, sunset would be right about there. So this is sunset. All right. Now our job when we're drawing a sun path is to connect these 3 points. So the easiest way to do that is to kind of turn the paper so that we're going to draw the sun path. So this up here, you know, has to be an arc, right? And it needs to connect from here, arc down to there. So we're going to kind of draw the path. We're going to arc it up top, and we're going to make that solar noon. And then we're going to come back down to sunset, all right? And we know that the sun rose on this side, and the sun was setting on that side. So you're also going to draw in the arrows on all 4 of these sun paths, okay? And we're going to do one more thing. This is during the day, right? Because this is the sun's path. Okay. But Polaris is there, even though we can't see it. Where would this person look to find Polaris? Well, Polaris is the North Star. So we know that it's in the northern part of the sky. This person is located at 41 degrees north. So how many degrees above the horizon is Polaris? 41 degrees above the northern horizon. So we're just going to make a little star, and we're going to label it Polaris. Okay? So this is your first sun path. You're going to draw the sun paths based on the data that you obtained from the simulator and the table for September 23rd, December 21st, and March 20th. And where you're going to get this data from, sunrise, sunset, and the height of solar noon, is when you collect that data from the simulator in this table. So when you're doing this, the easiest thing to do is to keep your lab open so that you can see your data. Okay? And then you're going to continue on from there. You're going to answer these questions. You can use the simulator to answer these questions. And you're going to do the same thing for 41 degrees south latitude. So change that to south. There are no sun paths for this, but there are questions about comparing north and south. So after you collect the data for 41 north, draw the sun paths, collect the data for 41 south, and then answer the question. So your job today and this weekend is to answer up to question 15 on page 5. Don't go any further than that. Okay, so work in class. do as much as you can, and then finish up through 15 this weekend. All right. I will see you guys on Monday. Bye.